Welcome to podcast number 50. Take a look at this function, and if you just recently did podcast 49, you'll notice that's the same function. And to set up the integral for the arc length, I could either do it with parametric functions or I convert it to rectangular. Since I'm going to have to convert it anyway, I think I'm going to do that first. So I took a picture of the graph, and one thing to notice is that x is going to range from a positive 1 on the right to a negative 1 on the left. And the y values are going to go up to 1, and then the smallest would be 0. Okay, so just keep that in mind and we'll come back to that. Then to convert this, so we need to use trig identities. One trig identity to use is that cosine of 2t is equal to cosine squared of just t minus sine squared of just t. And then that's good news because the x is equal to sine, so we'll be able to substitute that in. We'll just need to square it. All right, that's part of the good news. Then the other thing is this has a cosine of t, and so we need to replace that. So once again, back to the trig functions. So another trig identity is that sine squared plus cosine squared is always equal to 1. And that means we could solve for cosine squared. That would be 1 minus sine squared. And so this cosine squared gets replaced with 1 minus sine squared, and then minus the other sine squared. And that is what cosine of 2t equals. But if you look closely at this function, it says the cosine needs to be squared. So then I'll need to square both sides. So the left side would be cosine squared of 2t. The right side, I could combine like terms and say this is 1 minus 2 sine squared of t. And then the whole thing is squared. So now I can take the sine of t and it can be replaced with an x. So on the right side, it's going to say 1 minus 2x, and then it says sine squared, so that means x is squared, and then the whole thing is squared. And the left side is saying, well, that's what y equals. So that is our function. Now I just want to graph it and see if it looks like the same graph. So it is, go to y equals, erase this, and it is parentheses 1 minus 2x squared is squared. Oh, sorry. By the way, during the commercial break, I went to the mode and changed it back to regular functions instead of parametric. Okay, so then it's just regular y equals a function of x, and I've got it all typed in, and then graph, and you'll see that for the most part, it does look correct, except it should have stopped right there. So the x has to stop. This function doesn't know that, so it continues up like this. So it's supposed to stop right here when x equals 1. And then it's also supposed to stop over here when x equals a negative 1. So I just need to add that onto my work. So this is the correct function as long as you have x ranging between negative 1 and positive 1. Okay, so then the choice. Do I want to do the finding the arc length with the y function that I got, which then I'm going to have to do the power rule and then the chain rule, and I think I'm just going to use the trig functions. So when you're using the parametric form, then that means you take the derivative of each one. So let me make a little more space here. So you take the derivative of each one. So the derivative of x is going to be cosine of t. The derivative of the y function will be 2 times the cosine function And I still need a little more room. Sorry guys, it was great. Thank you for your help. Okay, back to my derivative. So I did the power rule, and then the derivative of cosine is negative sine of 2t, and then times a 2. Or in other words, the dy dt can be rewritten as negative 4, and then cosine of 2t, and then sine of 2t. And then for finding the arc length, you put the integral and then it's going to be the square root, and then the dx dt has to be squared, so that would be cosine squared of 2t. And then the dy dt has to be squared, so negative 4 squared is 16, and then cosine is squared, and sine is squared. And then what are the limits? So now I need to go back to the graph, and I need to change it back to the parametric form. Hopefully my function is still there. It is. This is what the graph looks like, but if you remember from number 49, it does this. It goes up to the top and then it repeats. So if I told it to integrate from 0 to pi over 2, it actually traces this graph more than once. So if we go from when t equals 0, let me just type that in. If we go from t equals 0, that will be the beginning point. And then from pi over 2, from there to pi over 2, so that would be the right side of the graph. So I could have it integrate from 0 to pi over 2 and then just double the answer. So 0 to pi over 2 will graph this once from here to here, and then because it's symmetric, just double the answer. And so just double the answer as it goes from 0 to pi over 2. And if it said you actually need to integrate, which it didn't, but if it did, the next thing I would do is factor out a cosine squared, then take that outside of the square root, and then do u substitution. But this one just said set up the integral. So we're done.